Your grandmother's last birthday didn't end. Right now, somewhere in the structure of the universe, she is still leaning over the cake, still blowing out the candles, and you are still small, and none of it is over. Not as a memory, not as a comforting story you tell yourself, as physics. Here is the part that should keep you up tonight. When someone we love dies, we say they are in the past, gone, behind us. But the equations that put satellites in orbit and land machines on other planets never say the past switches off. They say something far colder. The past is still there, it just isn't here. Convenient, isn't it, that the math and the morning don't agree? We feel time as a river, dragging us forward whether we like it or not, but the river isn't moving. The river is frozen solid, and you are a passenger sliding blindly across the ice, calling the scenery now. The moment you were born and the moment you will die are already sitting in their fixed spots, happening right now, just at different addresses. So if yesterday is still there, fully intact, why can't you turn around and walk back into it? For a universe that supposedly began as a random explosion of nothing, it came with a remarkably strict one-way lock on the door. To see how strange this is, go back to 1905. A young physicist named Albert Einstein asked a question a child could ask. If two lightning bolts strike at the same instant for someone standing on a train platform, do they strike at the same instant for someone racing past on the train? Run the math and the answer is no. Not because of a bad clock, not because of slow eyes, no, because at the same time isn't a real universal thing. There is no giant clock on the wall of the universe ticking the same now for everyone. 3 years later, in 1908, his old professor Hermann Minkowski took that result and said something that still sounds like science fiction. Space and time are not two separate things. They are woven into one four-dimensional fabric, space-time. Picture a giant uncut loaf of bread. The whole loaf is everything that has ever happened and everything that ever will. What you call right now is just one thin slice of that loaf. And here is the twist. Your slice and my slice don't have to line up. If you start walking, your slice tilts, just a hair, compared to someone sitting still. For everyday speeds, the tilt is far too tiny to notice, so scale it up. Point yourself at the Andromeda galaxy, 2.5 million light-years away, and take one casual step, about 1 meter per second. That single step tilts your slice of now across Andromeda by roughly 3 days. Turn and walk the other way, and it tilts 3 days the other direction. Two people brushing past each other on the sidewalk can disagree by nearly a week about what is happening right now in another galaxy. This is the Andromeda paradox, worked out carefully in 1966. Nobody sees the future. No signal beats light. But the universe flatly refuses to give one answer to a 5-year-old's question. What is happening everywhere right now? A hydrogen atom doesn't need a philosophy department to work this out. It just obeys it. So, the loaf is solid. Every moment of your life is baked in permanently. Which drags us back to the crime scene with one nagging question. If the past is really still sitting there, why can you only ever walk forward? If time were just another direction, like up, down, left and right, you should be able to stroll into last Tuesday the way you cross a room. But you can't. Something rigged the game. The culprit has a name, the Second Law of Thermodynamics. In plain words, the rule that things fall apart. A glass shatters on the floor, but it never leaps back together. An egg scrambles, but it never unscrambles. This is the one law in all of physics that actually cares which way time is pointing. It draws the arrow. But here is what keeps physicists staring at the ceiling at 3 a.m. For that arrow to exist today, the universe had to begin in a state of almost unthinkable order, near perfect tidiness at the very start. Think of a bowling ball resting on a trampoline curved so perfectly that a marble rolls around it in a flawless circle forever, never drifting, never falling. The Oxford physicist Sir Roger Penrose actually calculated how precisely tuned that starting order had to be. The odds he found were 1 in 10, raised to the power of 10, raised again to the power of 123. To simply write that number down as a 1 followed by zeros, you would run out of room. There are not enough particles in the entire observable universe to serve as the zeros. Let that sit for a second. Without that impossible tidiness at the origin, there is no arrow of time, no memory, no cause coming before effect. You couldn't finish a single thought. Randomness, apparently, sat the hardest engineering exam ever written and aced it, blindfolded, on the first try. We are told the beginning was chaotic and undirected, yet it landed on the exact one setting, tuned to a decimal point no human mind can picture, that lets a conscious observer sit here and experience the story in order. An accident that keeps passing the engineering review. So if the forward flow of time is really just a lock, the obvious human question is, can we pick it? In 1949, the mathematician Kurt Gödel handed Einstein an unsettling birthday gift. He found a hidden loophole inside Einstein's own equations. Rotate an entire universe, and space-time can twist so hard it loops back on itself. On paper, that is a road into your own past. The equations did not forbid time travel. They simply shrugged. But turning that math into a machine is where humans get humiliated. To bend the loaf that hard, you'd need the gravity of a spinning black hole or a rotating cylinder of ultra-dense matter, longer than anything we could ever build. So, we aim lower. We try to measure the fabric instead of bending it. Your phone's GPS depends on it. The atomic clocks on those satellites drift by about 38 millionths of a second every single day, purely because of their speed and weaker gravity. Ignore that tiny number, and within hours your map thinks you're in the wrong city. In 2022, researchers at JILA and the National Institute of Standards and Technology cooled a cloud of strontium atoms barely 1 millimeter tall and measured time running at different rates between the top and the bottom of that cloud. A pencil tip of height was enough for the geometry to show itself. NASA went further with the Deep Space Atomic Clock, launched in 2019 and retired in 2021. Toaster-sized and stable enough to lose about 1 second in 10 million years. Decades of work, whole careers, real budgets, to build a clock precise enough to obey spacetime's rules. It did not come with a button marked yesterday. Meanwhile, a single photon navigates this same four-dimensional structure flawlessly, for free, the instant it is born, with no funding and no mission patch. So go back to the photograph, your hand on the cold paper, the child in it. The people you have buried? The mathematics is telling you, coldly and without comfort, that none of it was deleted. That child is still there, at that exact address in the fabric. Your grandmother is still leaning over the candles. They are not erased. You are simply forced to keep moving away from their coordinate, unable to turn the car around. Grief, it turns out, is a navigation problem. But hold both facts at once. A four-dimensional structure that keeps every single moment perfectly preserved. A starting order tuned to 1 part in 10, to the 10th, to the 123rd. Clocks synchronized across an entire universe without one favorite, without a single caught contradiction, without ever letting one person wake up living yesterday and tomorrow at the same time. And we keep calling it an accident. If no plan drew this, if no hand set the dials, then answer the only question left standing. Who calibrated a clock this precise, and then hid the now from all of us so carefully that we mistook a frozen structure for a flowing river?